All right, welcome back to our final week of videos. And one thing I wanted to caution you about is that the first few examples you see are actually at the end of the week 4 slide deck. The PowerPoint presentation has a little of this starting topic in there, so I apologize for any confusion, but that's where I'm starting with. And basically what we're going to do is go from factoring to solving, and it's only one additional step, so that's the good news. If you felt really good about factoring last week, I hope you did, you're going to feel really good about this week because there's nothing new to learn with factoring. Okay, there's a couple of new techniques we're going to talk about when factoring doesn't work, but there's no more tricks to factoring. All right, so before we worked a problem like 9t squared minus 4 and we factored it, or x squared plus 6x plus 9, we factored it. Now we've got equals 0. So if you're adding equals 0 last week, you'll find that you missed it because we weren't solving without an equation. So if you don't have an equal sign, there's nothing to solve, but with an equal sign there is. And we're going to talk about how to do that using factoring. So a quadratic equation just means we have something to, x to the second as our first term. It's actually going to be graphed as a parabola. So the thing to remember if we're going to use the factoring technique is that if two things multiplied together equals 0, one of them has to be 0. Because if A is 5 and B is 2, we'll never get 0, right? One of them has to be 0, and that's the important part of this. So let's say we had an equation and we factored it and we got this. All we have to do is set each factor equal to 0 using the property we just talked about. And that's what you see here. X plus 4 equals 0 and x minus 3 equals 0, and solve for x. And we find that x can be negative 4 or 3. And if you check, you can pop each one into the original equation and you will get a true statement. That's all there is to it as far as solving by factoring goes. Okay, here's just showing that the check works. Here's another one, and remember you want to set each factor equal to 0. So 4 is equal to 0. Well, it's not, so we can discard that. But if that leading factor was like an x equals 0 is perfectly logical, and we would use that. All right, but 4 equals 0 is false, so we're not going to worry about that. But we will set each of the other factors equal to 0 and solve, and that's all there is to it. And then just check and make sure you got it. Same here, like this is an example I'm talking about. Set 3y equal to 0 and then y minus 7 equals 0, and you get your two solutions. So starting from the top, if you have an equation like x squared plus 9x plus 14 equals 0, and you're told to solve by factoring, all you have to do is factor the left side. Remember, it's got to be in equals 0 form. So everything has to be to the left and then set equal to 0. If it's not, I'll show you an example of that not being the case. But all we do is factor and set each factor equal to 0. Here's another great example. Remember, we have a greatest common factor here, and that's all we can do, which is fine, but then set x equals 0 equal to 0 and x plus 9 equal to 0, and then check. All right, so here's an example of what I was talking about. This is in the wrong format. It's okay, we can work with it, but we have to do something first. What we have to do is add 36 to both sides, because you see how that, how that minus 36 on the right shouldn't be there? We need equal to 0 on that side. So we're going to add 36 to both sides so that we have x squared minus 12x plus 36 equals 0. Then we have something we can factor, then we can set each factor equal to 0 and solve. And there's just one solution here, 6. It repeats. All right, another example, we've got to get it equal to 0, factor, and solve. This one looks scary, but don't worry. You still have to move everything to the other side. So what would we do? We would have to subtract 10x from both sides, and then we would subtract 6 from both sides. Then it's in a form we can work with, and then we can factor. So you can see that the factoring you learned last week is super important for this week's material. And this is what I think you're going to find is pretty cool. What this does is it'll tell you the intercepts, the x-intercepts. And this is going to be on your final exam. If you want to find the x-intercepts of a graph, set y equals 0. If you want to find the y-intercepts of a graph, set x equals 0. Setting x equals 0 in this case would make it pretty easy. We'd get y equals -8. All right, so even though you don't see it on this graphic, it crosses the y-axis at -8. And where does it cross the x-axis? Well, that's where we let y equal 0, and then it's no more difficult than the problems we were just doing. When we factor and set each factor equal to 0, we get -4 and 2. And all that means, let me kind of show you on the graph where that is. Here's -4 and 2. These are the intercepts. And that's why sometimes they'll be called zeros. If you're asked to find the zeros of a graph, it's where it crosses the x-axis. Okay, do not write the point -4, 2 as a solution, because that's not correct. You have two separate points that are your intercepts. All right, so I've got some applications to show you real quick, and then we will talk about other methods for solving if factoring doesn't work. So if you have a garden and it's a rectangular shape and you have an area of 270, the width is 3 feet less than the length, find the length and the width. Sounds really complicated. But if you let x equal the length, then the width is x minus 3. And so length times width equals 270. X times x minus 3 equals 270. Don't let x equal 270 and x minus 3 equal 270. You have to distribute, all right, and then subtract 270 from both sides. This is where we want to start. So the setup is really the hardest part, but you also need to make sure you have the correct form. And then we factor, set each factor equal to 0, and we have our two answers. But we can't have a -15 for a length, can we? So our answer is going to be 18. And 18 is x, so x minus 3 is 18 minus 3, or 15. So those are our two dimensions. All right, here's another one. I'll leave this for you. Again, it's at the end of the week 4 PowerPoint, but it just uses a formula, and most of the time a formula will be given to you. If it's not, you can ask me. My math lab might assume that you know the area of a rectangle or whatever, but if not, just ask me. But usually they put them there for you. And then our friend, the Pythagorean theorem. I love this. If you were to Google proof of Pythagorean theorem, you would find so many different ways you could prove that this little thing is true. And you've heard, I'm sure, a squared plus b squared equals c squared. But it means that if you take the leg and square it and add it to the square of the other leg, you get the square of the hypotenuse. The hypotenuse is the longest side across from the 90-degree angle. And this always works. It works with only right triangles. And what it does for you is it lets you find a side if the other two were given. So again, I'll let you look at this at your leisure, but it's just a nice little example of how that would work and how knowing what we know about factoring can actually help us solve it. So that's all I want to cover in this video. Join me for more methods of how to solve quadratic equations in the next video.